Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Input and output interfaces, often abbreviated as I/O interfaces, define the methods by which devices send and receive data with a computer system. These interfaces include both physical connectors, such as ports and cables, and wireless communication methods that do not require a physical link. The CompTIA Tech Plus exam FC0-U71 expects you to be able to recognize different connector types, understand interface capabilities, and know how they are applied in practical use cases. In this episode, we will focus on USB, Thunderbolt, radio frequency connections, Bluetooth, and other related technologies. The Universal Serial Bus, or USB, is the most common interface used to connect peripherals to computers and other host devices. USB supports not only data transfer, but also power delivery and device communication. The standard has evolved through several versions, including USB 2.0, USB 3.0, USB 3.1, USB 3.2, and USB 4. Each version offers different speeds and capabilities, while maintaining backward compatibility with earlier generations. There are multiple USB connector types in use today. USB Type A is the familiar rectangular connector found on most desktop computers and many peripherals. USB Type B is more square-shaped and is commonly used on printers and some external enclosures. USB Type C is oval, reversible, and supports high-speed data, video output, and power delivery through a single connection. Older devices may use mini USB or micro USB connectors, which are smaller and typically found on portable electronics and legacy equipment. USB's speed and power specifications vary by version. USB 2.0 supports up to 480 megabits per second. USB 3.0 and USB 3.1 Generation 1 support up to 5 gigabits per second. USB 3.1 Generation 2 supports up to 10 gigabits per second. Later versions, such as USB 3.2 and USB 4, can exceed 20 gigabits per second and may also carry DisplayPort video signals over USB Type-C. USB power delivery, often called USB PD, allows charging up to 100 watts. Many systems color-code USB ports to indicate their speed capabilities, such as blue for USB 3.x ports. Thunderbolt technology is a high-speed interface developed jointly by Intel and Apple. Thunderbolt versions 3 and 4 both use the USB Type-C connector, but provide faster speeds and more features than standard USB. Thunderbolt supports data transfer, video output for up to two 4K displays, and power delivery all through a single cable. It is common in MacBook systems, professional workstations, and advanced docking stations. When comparing USB and Thunderbolt, USB is more universal and cost-effective for general-purpose peripherals. Thunderbolt offers higher maximum speeds, supports daisy-chaining multiple devices, and delivers superior performance for demanding video and storage applications. However, Thunderbolt cables tend to be more expensive and may require certification. A USB Type-C port may or may not support Thunderbolt, so checking specifications is important. Radio frequency, or RF, interfaces are used by some wireless peripherals to communicate with a computer through proprietary radio signals. Examples include wireless keyboards, mice, and barcode scanners. Most RF devices connect using a small USB dongle that enables plug-and-play convenience. These connections typically provide longer range and lower interference than some Bluetooth devices. There are special considerations for RF devices. They are generally limited to paired transmitter and receiver sets and are not interchangeable between brands or models. The lower latency of RF connections makes them ideal for gaming peripherals where quick response is critical. However, they can be susceptible to interference in crowded wireless environments. These devices require either batteries or charging docks to maintain wireless operation. Bluetooth is a standardized short-range wireless protocol used to connect devices such as headphones, speakers, keyboards, mice, and various mobile accessories. Newer Bluetooth versions, such as 5.0 and above, offer increased range, faster data rates, and improved reliability compared to older versions. Devices pair using built-in Bluetooth radios and laptops, tablets, and smartphones, or through external Bluetooth USB dongles. Bluetooth versions offer different capabilities. Bluetooth 2.0 provided basic connectivity. Bluetooth 4.0 introduced Bluetooth Low Energy, often abbreviated BLE, which reduced power usage for devices like fitness trackers. Bluetooth 5.x improved both range and speed and added features such as mesh networking support. Bluetooth is used both for data applications like file transfer and sensor communication, and for media applications like audio streaming. Interference can occur when Bluetooth operates near Wi-Fi networks because both share the 2.4 GHz frequency band. Wireless interfaces in general offer benefits and drawbacks. They reduce cable clutter and allow greater mobility, but may experience signal drops, interference, or pairing issues. Wireless is ideal for users who prioritize flexibility over maximum speed. These connections require power management, either through replaceable batteries or rechargeable systems. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The Lightning connector is Apple's proprietary interface used on iPhones, certain iPads, and some accessories. Lightning supports data transfer, charging, and in some cases audio output through a single compact connection. Unlike USB Type-C, Lightning is exclusive to Apple products and does not have universal compatibility across other manufacturers' devices. Other proprietary interfaces may also be found in specialized devices, legacy industrial equipment, or older consumer electronics, where a specific connector was designed to match a single product line. Video output interfaces are also an important part of input and output connectivity. Common examples include HDMI, DisplayPort, VGA, and D versus I. I can carry both video and audio over a single cable and is widely used for monitors, televisions, and projectors. DisplayPort supports higher refresh rates and resolutions, and it can drive multiple displays from a single connector. VGA and DVI are older standards, with VGA being an analog signal and DVI offering a digital option, but both have largely been replaced in modern devices. USB Type-C and Thunderbolt connections can also carry video signals when paired with the appropriate adapters or cables. Audio interface standards allow devices to send and receive sound. The 3.5mm analog audio jack is the most common for stereo headphones and microphones. USB audio interfaces support headsets, microphones, and digital-to-analog converters, often called DAC devices. Bluetooth audio is increasingly common in wireless headphones, earbuds, and smart speakers. Some specialized systems use digital optical audio or proprietary connections for high-quality or low-latency applications. Docking stations and port replicators are devices that expand a single connection, such as USB Type-C or Thunderbolt, into multiple input and output connections. A docking station can provide ports for displays, Ethernet networking, audio, and multiple USB devices, all through one cable to a laptop. Port replicators are simpler devices that offer fewer expansion options and are generally less expensive. Docking stations are essential for professionals who connect a laptop to multiple peripherals regularly. Expansion can also be achieved through hubs and splitters. USB hubs expand one USB port into several additional ports, and powered hubs provide extra voltage to support more demanding devices. Passive hubs, or very long cable runs, can lead to signal degradation. Splitters can duplicate a signal, such as mirroring a video output to two displays, or route one type of connection to multiple destinations. Device compatibility and adapter use are important considerations when connecting peripherals. Not all ports and cables are directly compatible. even if the connectors physically fit. Adapters may be necessary to connect older devices to newer systems, such as converting USB Type-C to HDMI for a monitor connection. Some adapters can carry both power and signal, while others are limited to one function. Understanding the specifications prevents connection failures and avoids the risk of damaging equipment. The maximum data rate of an interface can be limited by the quality of the cable used. Certified cables are built to meet higher standards for shielding, construction, and performance, supporting longer cable runs and faster data speeds. Poor quality cables can cause data transfer errors, intermittent disconnections, or overheating during use. For mission-critical applications, it is recommended to use manufacturer-approved or certified cables. Each interface type has its own strengths and is best suited to specific use cases. USB is a general-purpose connection used for data transfer and power delivery for nearly all peripheral types. Thunderbolt is ideal for high-performance video output, fast external storage, and docking setups. Radio frequency wireless is best for reliable, low-latency input devices such as gaming mice or specialized handheld controllers. Bluetooth provides flexible short-range wireless connectivity for audio, input devices, and mobile accessories. HDMI and DisplayPort remain the primary interfaces for video output to monitors, projectors, and televisions. Security is an important concern for input and output interfaces. USB ports can be exploited as attack vectors by inserting malicious thumb drives or rogue devices. In enterprise environments, it may be necessary to disable unused ports or implement endpoint security policies that control which devices can be connected. Wireless interfaces such as Bluetooth can be intercepted or spoofed if not properly encrypted. Organizational information technology policies should include access control and monitoring for all interfaces. Troubleshooting interface issues starts with physical inspection of ports and cables. Bent pins, dirt, or debris can prevent a good connection. Using tools such as Device Manager in Windows or System Preferences in macOS can confirm whether the system detects the device. Updating device drivers, checking power supply adequacy, and applying firmware updates can often resolve connection problems. Swapping out cables or testing the device on another system can help isolate whether the issue lies with the interface or the peripheral itself. Different job roles rely on interface knowledge in different ways. Information technology support staff must be able to identify and configure various interfaces when setting up or troubleshooting systems. Field technicians often carry portable Bluetooth and USB tools for diagnostics and quick fixes. Audio and video professionals may rely on Thunderbolt, DisplayPort, and HDMI for connecting production equipment. Understanding input and output interfaces is essential for planning, repair, and ensuring compatibility in any technical environment. For the CompTIA Tech Plus exam, expect scenarios where you will need to identify a connector from a description, match it to a specific device, or resolve an interface-related problem. Some questions may require recognizing connector types from diagrams or photographs, while others will focus on comparing interface speeds, capabilities, and use cases. Mastery of these details will help you answer both theory-based and applied scenario questions accurately. Important glossary terms to review for this topic include USB, USB Type-C, Thunderbolt, radio frequency, Bluetooth, HDMI, DisplayPort, adapter, dock, and hub. Grouping these terms by function, such as data, video, wireless, or expansion, will help reinforce your understanding. If possible, review physical examples of these connectors to strengthen your recognition skills for the exam. In the next episode, we will look in greater detail at video connector types, including VGA, HDMI, DisplayPort, and USB Type-C video output. You will learn how to select the appropriate connector based on resolution requirements, compatibility considerations, and the type of signal being transmitted. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.